In this video, we will discuss the Pythagorean theorem. A right triangle has two sides that form a right angle, a square corner. These two sides are called the legs of the triangle. The side opposite the right angle, or the third side of the triangle, is called the hypotenuse. The Pythagorean theorem states that the square of the hypotenuse of a right triangle is equal to the sum of the squares of the two legs of the triangle. Here's the formula for the Pythagorean theorem. C squared equals a squared plus b squared, where c is the length of the hypotenuse of a right triangle, and a and b are the lengths of its sides. To find a leg or the hypotenuse of a right triangle, first identify the two known sides of the triangle and the unknown side and state the theorem symbolically. Second, substitute known values in the Pythagorean theorem, c squared equals a squared plus b squared. Third, solve for the unknown value. And fourth, the solution is the principal square root. Use the Pythagorean theorem to find the length of side B of a right triangle when A equals 8 millimeters and C equals 17 millimeters. Here, C squared equals A squared plus B squared. So 17 squared equals 8 squared plus B squared, which means 289 equals 64 plus B squared. 289 minus B squared minus 64 equals b squared. So 225 equals b squared. The square root of 225 is b, and the square root of 225 is 15 millimeters. So that's our length for b. Sometimes we are given problems that contain hidden triangles. In these cases, we need to visualize the triangle or triangles in the problems. Drawing one or more sides of the hidden triangle helps solve the problem. Find the center to center distance between pulleys A and C. Connect the center points of the three pulleys to form a right triangle. The hypotenuse is the distance between the centers of the pulleys A and C. Use the Pythagorean theorem and substitute the given values for the two known sides. AC squared equals AB squared plus BC squared. So 15 squared, that's 15 squared plus 10 squared, which is 225 plus 100, which is 325. So AC equals the square root of 325, which is approximately 18.0 inches to the nearest tenth. Sometimes right angles are used to represent relationships, such as forces acting on an object at right angles or electrical and electronic phenomena related in the way the three sides of a triangle are related. Forces A and B come together at a right angle to produce force C. If force A is 74.8 pounds and the resulting force C is 91.5 pounds, what is force B? Since the forces are related in the way that sides of a right triangle are related, we may use the Pythagorean theorem to find the unknown force B, a leg of the triangle. We first solve the equation for B squared equals C squared minus A squared, then plug in values and solve. B squared equals 91.5 squared minus 74.8 squared, which is 8,372.25 minus 5,595.04. And from that, we get 2,777.21. So B is the square root of 2,777.21, which is 52.7 pounds. An isosceles triangle has two equal legs. An isosceles right triangle is a right triangle that has equal legs. The angles opposite the equal legs are base angles of an isosceles triangle. The two base angles are also equal because they are the angles associated with the equal sides. The sum of the angles of a triangle is 180 degrees. The sum of the two base angles of a right triangle is 180 degrees minus 90 degrees, or 90 degrees. If both angles are equal, as in the isosceles right triangle, then each angle is 1/2 times 90 degrees, or 45 degrees. These base angles are complementary. A 45-45-90 triangle is an isosceles right triangle. The two base angles are each 45 degrees. This triangle is frequently used in applications of the Pythagorean theorem. All isosceles right triangles have the same relationship between each leg of the triangle and the hypotenuse. If the length of a leg of the triangle is x, the length of the hypotenuse is x times the square root of 2. By extension, if the hypotenuse of an isosceles right triangle has length x, its legs have length x divided by the square root of 2. To find the hypotenuse or leg of a 45, 45, 90 triangle, identify the known and unknown parts of the triangle and substitute in the formula h equals L times the square root of 2, where h is the length of the hypotenuse and L is the length of a leg. Then solve for the unknown value and write as an exact solution or approximate solution as desired. For example, find the hypotenuse to the nearest thousandth of an isosceles right triangle that has equal sides of 2 meters. Let L equal 2 meters, the length of a leg of the triangle. Then h equals L times the square root of 2 equals 2 root 2 meters. This is the exact solution. However, we are looking for the solution to the nearest thousandth, so we multiply out 2 times the square root of 2 is approximately 2.828. To the nearest thousandth of a millimeter, the hypotenuse is 2.828 meters long. In the figure below, find the lengths of AC and BC. Here we have the length of the hypotenuse, h equals 5 centimeters, and want to know the length of the legs. It's an isosceles right triangle, so the legs will have the same length. We saw before that if we know the length of the hypotenuse of an isosceles right triangle, the length of a leg is h divided by the square root of 2. So here, L equals 5 divided by the square root of 2, which is 3.536 centimeters to the nearest thousandth of a centimeter. Another triangle commonly used in applications of the Pythagorean theorem is the 30, 60, 90 triangle. If we draw the altitude of an equilateral triangle, we form two 30, 60, 90 triangles. The altitude of an equilateral triangle is a line drawn from the midpoint of the base to the opposite vertex, dividing the triangle into two congruent right triangles. Because the altitude of an equilateral triangle bisects the vertex angle and the base, two 30-degree angles are formed at B and AC, and AC equals 3 CD. We can also say that AC is 1/2 of AD, or 1/2 of any side of the original equilateral triangle. That means that AC equals 1/2 AB, or the side opposite the 30-degree angle is 1/2 the hypotenuse. We can apply the Pythagorean theorem to find the height of a 30, 60, 90 triangle, or the side opposite the 60-degree angle. When x is the length of the side opposite the 30-degree angle and 2x is the hypotenuse, the height is x times the square root of 3. To find the unknown sides of a 30, 60, 90 triangle, first identify the known side of the triangle. If the side opposite the 30-degree angle is known, substitute in the formulas hypotenuse equals 2x, height equals x times the square root of 3. If either the hypotenuse or the height is known, use the appropriate formula and solve for x. Use x and the remaining formula to find the remaining side. Find AB and BC if AC equals 7 inches. Since AC is the side opposite the 30-degree angle, the length of the hypotenuse, AB, is twice the length of AC. 2 times 7 equals 14 inches. BC, the height of the triangle, is x times the square root of 3 equals 7 times the square root of 3, which is about 12.1 inches. The height of a 30, 60, 90 triangle is 8 centimeters. Find the length of its hypotenuse and the remaining side. It is easy to find the short side of the triangle first, since we know that if x is the length of the short side, the height of the triangle h is equal to x times the square root of 3. Solving for x, we get h over the square root of 3. So x equals 8 divided by the square root of 3, which is about 4.6 centimeters, approximately. The hypotenuse is then simple since it is just twice the length of the shortest side. H equals 2x, which is 2 times 8 times divided by the square root of 3, which is about 9.2 centimeters.